Now, this question is about CSMS-CD. Question is saying that the network consists of 4 hosts distributed as shown below. So they are talking that there are 4 hosts A, B, C, D, and they are all distributed like this using CSMS-CD. And signal travels with a speed of 3 into 10 power 5 kilometers per second. What is 3 into 10 power 5 kilometers per second is? It is nothing but 3 into 10 power 8 meters per second. If the sender sends at 1 Mbps, which means the bandwidth is 1 Mbps, what could be the minimum size of the packet? That is what they are asking. So one thing is, generally CSMS-CD is used in a broadcast channel or in a bus topology, or star if it is implemented as hub. Either CSMS-CD, if it is implemented using a wire, it will be a bus topology that was initially used, and later they are using either hubs or switches, which means star topology. These are the two popular topologies which are the two topologies which are popular for our CSMS-CD. But then if you look at this one, it is a bit different in the sense it is a kind of mesh, isn't it? It is a mesh topology. It is a point to point, but still they are saying that every node is using CSMS-CD for access control. It is actually not a valid question in the sense, it is not practical in the sense, if it is a point to point channel, if you have a full duplex wire, there is no need of access control at all. Both A and B can transmit data, and they can transmit data at the same time. This question is just given so that for the sake of creating a question. So anyway, we could solve it. So what they mean to say is, what they mean to ask is, if CSMS-CD is used in this and a signal is having 3 into 10 power 8 meters per second, and then there are 4 hosts, and where is the bandwidth? And the bandwidth of I think a sender is sending 4 hosts 1 Mbps. So bandwidth is 1 Mbps, and it is so, and the distances are given. Then they are asking about the minimum packet size that should be used in CSMS-CD. So we know that the minimum packet size in CSMS-CD is L is greater than or equal to 2 into TP. TP is D by V into bandwidth. Therefore you should take each one into consideration and compute for everything what is the length. So what we wanted is minimum length, but it is a tricky question in the sense you might think that in order to get the minimum length of the packet, so you should decide about the size of the packet which should be able to survive all the distances. So why is there a limitation on the size of the packet? Always remember that there is a limitation in the size of the packet so that we could detect the collisions, which means if you remember it, I told you that if there is a signal going on, if there is a collision, even if the collision is at the other extreme, by the time the collision signal comes back, you should still be transmitting the data. That is why you should have that much amount of data, so that by the time the collision signal comes back, you should still have the data at hand. That is why we had this restriction on minimum amount of data, right? Now you come up with a minimum amount of data which could survive all these lengths. The problem is, if you directly try to put the minimum distance among all the distances available here, what is the minimum distance? I think 40 kilometers. So if you take 40 kilometers and if you put it here, yes, the packet will be able to detect the collisions in this line, isn't it? But then it will fail to detect the collisions in any of the other lines because they have higher distance, and therefore we need larger packets. So in order to solve this question, we should have the packet which should be able to survive, we should survive even the longest length, so that if a packet is able to survive the longest distance, it will definitely be able to survive the shorter distances. So in order to solve this question, even though they are asking about the minimum packet size that should be used, you should take the maximum length of the data, which is nothing but 90 kilometers. You should take 90 kilometers and you substitute here. If a packet is able to overcome 90 kilometers and detect the collision, then definitely it will be able to overcome any of the other distances and detect the collision. So please read the question carefully. So assume that network is a CSMS-CD, and this, if the sender sends it, what could be the minimum size of the packet? That is what is given, but then the question has to be extended this way. What should be the minimum size of the packet so that it could survive in all the networks? If they ask about only the minimum size of the packet, you could take 40 kilometers and you will get the minimum size of the packet. But that is not what their intention is. I think what they suppose, but it is not given in the question. I think what they supposed to ask is what should be the size of the packet which should be surviving in this entire network. Only one frame should survive entire network. Then that frame should be able to survive 90 kilometers. If it can survive in 90 kilometers, it can survive in any other distance. Therefore, the answer is this one, 600 bits. If you substitute here, you are going to get 600 bits, I guess. Please, you please substitute here. So what is it? 2 into d by v. What is d? 90 kilometers, which means 90 into 10 power 3 divided by 3 into 10 power 8. I converted everything into meters into bandwidth. Bandwidth is 1 Mbps, 10 power 6. So how much you are getting? 30 is 600. Therefore the answer is 600 bits. I think 600 only. Maybe you could just do it. It is 8 and it is 9, yes, 600 meters. So the packet should be at least as big as 600. So it is, even though they are asking about the minimum size, what they mean to ask is what should be the size of the packet so that it survives in the entire all the networks of all the distances. Okay.